Hello dear friends, welcome to my channel. Today's discussions is recursive functions and data type revisited. Okay, recursive functions I have just discussed only that what is the recursive functions. Today I want to give one example of the recursive functions. So friends, let's start our program. Hash include stdio dot h. Hash include stdio.h. Okay, include okay. Hash include stdio.h and void void main void main. Okay, before the void main I need to create a recursive functions. So it is int rec int int and int a comma fact int a comma fact printf. Printf slash okay slash n enter any number. Okay, enter any number semicolon and next scanf percentile d okay comma a. Okay, so enter the scanf, enter the input value. Scanf means input value and also it is closed with semicolon. Next is fact equals to rec a. Printf printf factorial values. Okay, 1 minute. Printf factorial value equals to percentile d fact. So next I start my function work. Okay, int rec int x. So this is the int rec int x, and let's start this function. So int f comma if x equals to 1, then return then return 1. else else if equals to x star rate x minus 1. Return if and comma and this. Okay, this value. Okay, I hope that I cleared this function. Let's see that there is a syntax error is percentile d a. Okay, enter int a fact. Okay, this is the correct enter. Okay, there is an addressing. Okay, addressing values I have to give. So where is my addressing? Okay, there is addressing value. Let's see that where is the. Okay, scanf addressing a percentile d fact rec a. Okay, percentile d. Okay, scanf. Okay, scanf spelling is wrong in here. Scanf. Okay, next else. In here I must include else. Next enter any value. So if I put 4, next I get value and clear this, and again run the program, enter any value. So it is 5. So I get the value is factorial value 120. So similar way, let us understand this recursive factorial function thoroughly. In the first run, when the number entered through scanf is 1, let us see what action does rec take. The value of a is copied into x, since x turns out to be 1. So to be 1, the condition if x equals to 1 is satisfied, and hence 1 is returned through the return statement. When the number entered scanf is 2, the x equals to 1 test fails, so we reach the statement. So friends, I will discuss it in theoretically. So theoretically, but you will just listen to my to my lectures, that f equals to x star rec x minus 1. here is where we meet recursion. How do we handle the expression x star rec x minus 1? We multiply x with rec x minus 1. Since the current value of x is 2, it is same as saying that we must calculate the value 2 star rec 1, and we know that the value returned by rec 1 is 1. So the expression reduces 2 star 1 simply 2. Thus this the statement x star rec x minus 1 evaluates to 2, which is stored in the variable f, is returned to main, where it is duly printed as factorial value equals to 2. Now perhaps you can see what would happen if the value of a is 3, 4, 5, so on. So friends, I will discuss it more in my theoretical class. This is the practical. In my next, this is the first is practical. Next I will discuss it in my theoretical class. Hello dear friend. So friends, I have already discussed this programming, that recursive programming. You will check in my practical videos. So in practical, now I want to discuss theory, that what is recursive and stack. Okay, so see, this problem is based on recursive. Okay, so in case the value a is 5, okay, in the k is value is 5, 5 main would call rake, main would call rake, and main would call rake with 5 as its actual argument, and rake will send back computed value. Before sending the computed value, rake calls rake. Okay, so rake calls rake and waits for a value to be returned. It is possible for the rake that has just been called to call yet another rake, and the argument x being decreased in value by 1 for each of these recursive calls. This is the recursive calls. Okay, argument is recursive calls. So this is very important. I again repeat whatever I want to say. The argument x being decreased value by 1 each of these recursive calls. We speak of this series of calls is rake as being defined invocation of rake. These successive invocation of same function are possible because the C compiler keeps track of which invocation calls which. This recursion invocation end finally when the last invocation gets argument value 1, which of the preceding invocation of rake now use to calculate its own f and value, and so on up the ladder. So we might say what happens, rake 5 returns rake 5 returns 5 times, of rake 4, and which returns 4 times rake 3, and returns 3 times rake 2, and returns this is the up to 1. Okay, so well, that is recursion for you, the simplest graphs. I hope you agree that it is difficult to visualize how the control flow from one function call to another. Possibly my figure would make things a bit clearer. So my figure, you see that from main it calls to the, this is the calls rake int. Okay, calls rake int x, and return f to main, and rec x minus 1 is go to the return f, and rate x minus 1 is in here, and x minus 1 rec x minus 1 is going to return 1, and rec x minus 1 is go to the rec int x. So this is the flow. Assume that the number entered through scanf is 3. Using 5 point, using the figure, let's visualize the exactly happens when the recursive function rec gets called. Go through the figure carefully. The first time when rec is called main, x collects 3. From here, since x is not equals to 1, rec equals to 1, the if block is kept, and rec is called again with argument x minus 1. If block is skipped, rec is called again with argument x minus 1, that is 2, and this is recursive call. And since x is still not equals to 1, rec is called yet another time with argument 2 minus 1. This time as x is 1, control goes back to previous rec with the value 1. F is evaluated as 2. Similarly, each rec evaluates its f from the return value, and finally 6 is returned to main, and sequence would be grasped better by following the arrows shown in figure. This figure arrow is shown in this figure. X minus 1 again call rec, okay, rec in int x, and when it is x minus 1 again the follow rec int x, and return 1 when it is 1, so it is x minus 1 is equal to 1, so this is the return 1, okay. This is the flow, okay, flow direction arrow. I will give arrow, I want to give arrow, that arrow is very clear. X minus 1 return 1, then it is x minus 1 call, and again this is the flow is in here, and return f is to main. This is the flow. Let it be clear that while executing the program, there do not exist so many copies of the function rec. These have been shown in the figure just to help you keep track of how the control flows during the successive recursive calls. Recursions may seem strange and complicated at first glance, but it is often the most direct way to code an algorithm. Once you are familiar with recursion, the clearest way of doing so. Recursion and stacks. There are different ways in which data can be organized. For example, if you are store 5 numbers, then we can store them in 5 different variable and array. A linked list, a binary tree, etc. All these different ways of organizing the data are known as data structures. The compiler uses one such data structures called stack for implementing normal as well as recursive functions calls. So friends, I hope you can understand this program that recursion calling, each recursion is the calling call another recurse, and this way a circular movement, it is end when rec x is equals to 1. It is stop the function, it is stop when if x equals to 1, then return 1, otherwise this flow is continuing. So you can create a lot of program. This is the Fibonacci sequence, a lot of program you can, sin x, a lot of program you can create for your exercise. Now I want to just give idea about the data type revisited. A scene as seen in the first chapter, the primary data types could be of three variables: char, int, and float. It may seem odd to many how C programmers manage with such a teeny set of data types. Fact is, the C programmers are not really deprived. They can derive many data types from these three types. In fact, the number of data types that can be derived in C is in principle unlimited. A C programmer can always invent whatever data type he needs. We would Okay, so not only this, the primary data types themselves could be of several types. For example, a char could be char, could be an unsigned char or signed char. So it is unsigned char, unsigned char, and signed char. Or int could be short int and long int. So short int and short int and long. To fully define a variable, one needs to mention not only its type but also its storage class. In this chapter, we would be exploring the different storage classes and their relevance in C programming. Integers and long and short. We had seen earlier that the range of the integer constant depends upon the compiler. 16-byte compiler like Turbo C and Turbo C++, the range -32768 to 32767, minus 32767 to 327, okay, 67, no sorry, not 8, 32767. 32-bit compiler, the range is also, when it is a 16-bit, the bit is 16-bit, the bit is 16-bit, and 32-bit, when the bit is 32, then it is minus 214 21474 7483 6482 plus 214 744 83647. So this is the 30. Here 16-bit compiler means that when it compiles a C program, it generates machine language code that is targeted towards working on 16-bit microprocessors like Intel 8086, 8088. Intel 8086 and 8088. So friends, 16-bit turbo C++, short int long 2224, 32-bit visual C plus 244. This is the sizes. Integers based upon size of the defined integers. Shorts are at least 2 bytes big, longs are at least 4 bytes big. Shorts are never bigger than ints are never bigger than longs. I hope I give some little bit idea. Thanks for watching.